8th grade, let's do ourselves a little bit of reviewing for your upcoming test. I'm going to present here. Remember, I would always jot this stuff down on a piece of paper just because it's pretty crucial for you to figure this out. So here we go. Hopefully you actually did this test and didn't. Well, we won't go there. Let's just get after it here. A piece of fabric is in the square shape of the square. The area of the measure is 28 square inches. Find the length side of one of the sides. Well, ladies and gentlemen, here's the spiel. This is the way this works. Keywords here. It's a square. That means both of the sides have to be the same. So we'll pick the letter S to stand for side. I know that's a stretch for you, but that's the way it is. How do we find the area of a square? We multiply the two sides together. So side times side has to equal this 28. Which means, boys and girls, S squared equals 28. Now, if I want to find just one S, and again, you can kind of think of the opposite. The opposite of square root, or squares, is square root. So just one S equals the square root of 28. Now, the bad thing about the square root of 28 is, ladies and gentlemen, it is not simplified. So S does equal 28, but you can break down the square root of 28 into the square root of 4 times the square root of 7. And the square root of 4 is 2. So your answer is 2 times the square root of 7. That's what one side length would equal. Boom, 1 down, 2 to go. Corinne runs at 6 miles per hour. What is her rate in miles per minute? Again, a simple unit multiplier will fix this for you. 6 miles per hour. And I want to change that to miles per minute. So the label I'm trying to change is hours. So if I have hours on the bottom, I have to put hours on top. I'm changing hours into minutes. And 1 hour equals 60 minutes, which is good because my hours cross off. And I can do some cross canceling here. 6 goes into 6 once and into 60 10 times. Here's what you end up with. Multiplying the tops together, you get 1 mile per 10 minutes. Now, we would not necessarily say it like that. You wouldn't say I go 1 mile per 10 minutes. You would take this beginning fraction and you would say I go 1/10 of a mile per minute. 1/10 of a mile per minute would be the better answer to 1 mile per 10 minutes. 1/10 of a mile per minute. Wow, that was fun, exciting as well. Problem number 3, if you have 3 square roots of AB and you take 6 of them away, you have 3 of them. It's going to take me a second to draw those, but I'm taking away 6 of them. I have many more that I'm taking away than I have. You have squared AB squared. Okay, boom. You know, this and this will cancel out. This and this will cancel out. This and this will cancel out because they're pluses and minuses. You have a balance of a -3 square roots of AB. Remember, the square roots don't change. They're like variables. You know, they stay the same no matter what you're doing. Unless you're multiplying, and you multiply them, then they change. But we are adding and subtracting there. Following the order of operations for number 4, we have to do parentheses first. So 8 minus 2 is 6. Rewriting all this stuff. Then doing the exponents there. 6 times 6 is 36. Boom. And 36 plus 4 is 40. Now, if there's one place I see people go wrong, they think they can do this 3 minus 4 first and then multiply. No, order of operations say you have to multiply first. So you get a -160. And 3 minus 160. Okay, My negative number is way bigger than my first. Remember, you subtract no matter what. I'm going to get 157, but the negative number is bigger, so it's a negative 157. Negative 157. Problem number 5, the only thing bad about this, nothing really cross cancels, but you can't leave that negative, so you have to move it to the bottom. There's nothing left on top, so I put a 1. I end up with an a squared and a b to the 4th. Nothing more can be done there. It just ends up being that. Wow, we are on some sort of breakneck speed here. This might get done faster than I thought. Let's go with the green on this. Remember, this is FOIL. I'm not sure what the book is going with here, but they give you a negative here, which is something we don't always see, but still done the same. You do the 2 first terms. 2 times a negative 3 is a negative 6, and you have x squared there. The 2 outside terms, 2x times 3 is 6x. The inside terms, 2 negatives make it positive 6x. And the 2 last terms, negative 2 times positive 3 is negative 6. Wow, 6s are wild. And then, like usual, the middle 2 terms will combine. You get negative 6x squared plus 6x, and 6x is 12x minus 6. Again, I'm not sure why they threw that negative first term in there, but you know what? You're grown-ups. You can handle it. You're smart enough, fast enough, strong enough. Problem number 7, a street light casts a shadow of 36.4 feet long. The child who's 3 feet tall. They give you the whole pictures here. These are just similar triangles, and I would draw myself a ratio box. I would compare the small triangle to the big triangle. We have the height compared to the shadow. The small triangle height is 3. The small triangle shadow is 5.2. Gotta like decimals. The big triangle height we do not know, but the big triangle shadow is 36.4. You gotta like this. This is your equal fractions. I'll do it up here. Well, yeah, I can do it down here. So it's 3 over 5.2 equals x over 36.4. I suppose this calls for cross-canceling. Believe it or not, you probably could do some other stuff, but hey, so we're cross-multiplying, not cross-canceling. 5.2x equals 3 times 36.4. 36.4 times 3, 12, 18, 19, 1092 with a decimal point right there, 109.2 equals 5.2x. What's the chances this is all going to work out nicely? Somebody say please. Divide by 5.2. Divide by 5.2. I'll do that up here. 109.2 divided by 5.2. Move the decimal. So there's no decimals here at the end. 52 goes into this twice, which is 104. Oh, look at that. Goes in there evenly. X is 21 feet. How about that? You always know you did it right when it works out evenly, especially something like that. Isn't that exciting? Oh, number 8 is a good one, ladies and gentlemen. How do we know about parallel lines? We know parallel lines because they have the same slope. So the problem with that is this is in slope-intercept form, so it's really easy to find the slope. And this one is not. You do not have to graph this. I mean, you probably could and get the answer yes or no, but the simple gist of this is you need to solve this for y. If you solve it for y and you get this fraction in front of x, you know that they are parallel. And it's a pretty easy solve. I just move my 2x to the other side, which means I'm going to rewrite it like this. 5y equals, I move the 2x to the other side, so I add 2x to it, plus 30. and then I just need to divide by 5. And you can stop right here. You don't need to worry about this because I'm only worried about the slope. And the slope is 2 over 5, 2x. So the answer to this is an overwhelming yes, they are parallel. Very nicely done. And here we go. Solving the inequalities. I just need to solve for x, so I add 6, and I add 6 to that. So x is greater than or equal to 4. I graph that here at 4. X is greater than. Oof. This one here. Some bells and whistles ought to be going in off in your head, ladies and gentlemen, because this is negative, and that's a bad deal because a lot of stuff's gonna change. But first, let's get rid of this dividing by 3 by doing the opposite and multiplying both sides by 3. These 3's go away. I'm left with a negative x is less than 6. Now, I change this to its opposite, becomes a positive x. I change this to its opposite. I change this to its opposite. And you do that, you can either think of dividing everything by -1 or multiplying by -1. It doesn't matter. You get the same thing. So that sign will change sides, and you end up with a -6 open circle because there's no equal sign under it, and graphing everything to the larger side of that. Wow, halfway home, kids, halfway home. Maybe not such a bad test. Problem number 11, Nick is typing a research paper on his computer. His typing speed is inversely related to his typing time. If he is typing 45 words per minute, it will take him 4 hours to type his entire paper. How long will it take him if he types 30 words per minute? Inverse variation. A couple ways to do this. Probably the easiest way to do this is, well, maybe I'll do both of them for you. I don't know. You know that x1 times y1 has to equal x2 times y2. In other words, instance number 1. Let's make 45 my x, sub 1, and my 4. 45 words will take 4 hours. That has to equal 30 words times how many hours? It's just as simple as that. And 4 times 45 is what? 180 has to equal 30 times what number? Divide by 30. Divide by 30. And it's going to take him 6. And would have to equal 6 hours. Okay, just know that this has to equal the same thing as this times whatever number is. That's inverse variation. And you know you did it right because look at the words went down and the time went up. They went opposite. We'll just stop with that. Oh, a square photograph has a side length of 5n. Not another square problem, just like problem number 1. Here's a square photograph. Has a length of 5n centimeters. That means all sides are 5n. The area of that is simply, area equals s squared, side squared. So area equals 5n times 5n. And when you get that area multiplied out, you get 25n squared for your area. 25n squared. Centimeters squared, by the way. Guess we should label that. Oh, 13, solving by elimination. You knew they were going to throw a little wrench into the situation here. The problem with 13 is when you solve by elimination, you want the equations to be written in the same form so that the x is under the x, the y is under the y, and the numbers over here. So you're going to have to rearrange the terms here. So I'm going to rewrite the top one the way it stands. I'm just going to move the x over here by subtracting 3x. So this is going to be a minus 3x plus 3y, and that's going to still equal that 9. In order to do elimination, they have to be lined up one on top of the other. And then here, in order to do elimination, remember you have to have the same opposite things. So the easiest one to change would to make both of these 6, because this is already a negative, that's a positive. So I'm going to multiply everything by 2. And when I multiply those by 2, I get a negative 6x, a positive 6y, and a positive 18. So this is now gone. Don't have to worry about that anymore. When I add them together, the 6x and the negative 6x cross cancel. Positive 6y, negative 4y is 2y, and 18 minus 8 is 10. So I divide by 2, I divide by 2, y then equals 5. Not quite done, because then I need to solve for x. I would probably take this y and put it in right here for that y. So I get 6x minus 4 times what I found y to be equals negative 8. This becomes a negative 20, to which I'm going to add 20 to get it to the other side. So I get 6x equaling 12, and x equals 2. So 2 comma 5 is my answer. That solves both of those equations. X equals 2, y equals 5. Number 14, a boat travels at a constant speed shown below. What is the rate of change, ladies and gentlemen? All they're asking for is the constant of variation. In other words, for problem number 14, the rate of change is simply what do I multiply this by to get that. I guess we could talk about it in terms of slope, but you know, the rate of change is simply going to be 35. What is the rate of change? It is 35. It's your constant of variation. Remember, it's the change in y over the change in x if you want to do it. But just say to yourself, 2, just write an equation. 2 times what number equals 70? 2 times what number equals 70? Divide by 2 and divide by 2. N equals 35. That is my rate of change. Well, here's a slope problem, which means you had better write down the said fair slope formula. Slope equals y sub 2 minus y sub 1. Please make sure your y's are on top, over x sub 2 minus x sub 1. I again would make these the x and y, make these the sub 1s, and make these the sub 2s, just for consistency's sake. So y2 is negative, won't break my own rule here, children. I'm going to put parentheses for those. Parenthesis minus parenthesis over parenthesis minus parenthesis. Y sub 2 is negative 3 minus y sub 1, which is 4. X sub 2 is 3 minus x sub 1, which is 2. And a negative 3 and a negative 4 is a negative 7. 3 minus 2 is 1. So technically this has a slope of negative 7. Slope of negative 7. By the way, I don't have the answers here, so I'm taking a shot at it that I'm getting these right. There's a good chance. I told you I didn't do very well in Algebra 1, so I'm still scarred by that. Supermarket marks down the price of a $3 loaf of bread by 15%. What is the discount and the new price? Hopefully by now you are onto this little thing here. This is a discount. I'm going to do my percent box. And this is an original minus the discount equals the final price. So here's my percent, and here's what the price is. A supermarket marks down the price of a $3 loaf. So it started out being $3. The original percent is always 100%. This is how much it goes down. It goes down 15%. So that means the final price, you will pay 85%. What is the discount? Oh, they give it all to you. You need to find both of those, the discount and the final price. So let's just go with the discount, I guess. So 100 over 15. 100 over 15 equals 3 over what number? And this is pretty easy because we're divided by 100. So 3 times 15 is 45. And that has to equal 100n. So if I divide 45 by 100, just moving the decimal back 2 places, my discount is going to be, I move that decimal over, 45 cents. My discount is 45 cents. So my final price, if I take 45 cents away from $3, I will have to pay $2.55. Common consumer mathematics, people. Discount 45 cents, final price $2.55. Making a box and whisker plot to display said data in math class. You know what? In the interest of time, I am going to ixnay this L problem A. We're going to skip 17. Skip 17. I'll tell you what, if you have time, do that last, and I will give you extra credit for it if you want to do it. But right now, I've got some time constraints that we need to deal with. And that just takes a long time. So if you want to do it, you feel confident about it, and you have the time, by all means, take it in. What is the probability of rolling 2 identical numbers or rolling a sum of 6 using 2 number cubes, each labeled 1 through 6? Oh, mercy. You had better, you probably, I'm going to go in search of, by the way, here. You would probably want to use your that number cube thing I gave you, and I'm going to go find it because to sit here and write it all up, I'm not just going to do that. Much as I like you kids, I am going to find it, pull it up, look at it, talk about it. You'll like me. You'll love me for that a little bit later. Algebra 1. What was it? What did we just do here? I know we did it. Frequency distribution. I think that was it, wasn't it? Let's try that. Great. And it's not filled out, but here we go. I'm just going to copy the table. We'll put it over on our thing there. How about that for being big enough? Kind of covers everything up, doesn't it? Let me make it small enough so we can see it. Maybe a little bit bigger. What do you think? Okay, so here's the deal. Here's the deal. What is this? 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. So you're going to want to have this little table with you. 8, 9, 10, 11, 12. So I'm looking for, ladies and gentlemen, the probability of rolling either 2 identical numbers, that would be double 2s, double 3s, double 4s, double 5s, or rolling the sum of 6. So let's look at that. And we are adding those probabilities together, and then we would be subtracting the times that they both happen together. Okay, so you know that this, let's do it a different color. Make it smaller, sir. I think I made this a little too big. Okay, here's a double, 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 there's a double. So remember, there's 36 things there, and 2, 4, 6 of them, 6 out of 36 are doubles. Sums of 6s, there's 1, 2, 3, 4. 5 of them are 36. But there is one time right here where they both happen at the same time. So I have to subtract that 136. So I get 1136 minus 136. I get 1036 as my probability. And of course, we reduce that to 5/18. Again, taking a shot that I'm right on that. I should probably take a look at that, but you know what? We'll look at it later. Number 19, identify the constant of variation when y equals 6, when x equals 3, given that y varies directly with x. And all that is this. Remember, ladies and gentlemen, again, good thing you're taking notes here. Your constant of variation equation is y equals k times x, where this is the constant of variation. I might make this just a touch smaller, maybe a little bit smaller still. Y equals kx. So you just plug in the numbers. Y is 6, boom, and x is 3. So if I am solving for the letter k, which is the constant variation, constant of variation, you just divide by 3 to get k by itself. So k equals 2. So the equation of variation would simply be this same thing, except you put 2 in for k. So y equals 2k. Oh, look, y 2k. How about that? You weren't alive for that, so it probably wasn't quite as funny to you as it was to me. And the last one is to solve the system of equations below. Solve the system of equation below. I guess, children, you get your choice as to how you want to solve this. Do you want to solve it by graphing, by elimination, or by substitution? Gosh, what would you prefer? I guess it's up to you. Because one of them, I don't know if this will make much sense to you or not, but because one of them, because it's a fraction, it doesn't lend itself well to, well, maybe we'll do it all 3 ways. We got lots of time. Me, personally, I probably would do this. Because this is solved for the letter y, I would probably use substitution because I know it looks like it's going to cross cancel. So here, let's do that. I'm going to put this in for y right there. See if you can make heads or tails of this. So I have, I have 4x right here minus 10 times what y is. And y is 2/5 x minus 2. And that all equals 20. Like I said, that's not a bad deal because I know this fraction is going to go away because of the 10 and the 5 on the bottom. So I end up with this 4x. 10 cross cancels with the 5. 10 over 1 gives you 2, 4. You get a negative 4x. That's going to be interesting. And a negative 10 times a negative 2 is a plus 20. And that equals 20. Oh, this is going to just get absolutely bizarro here. If I do what I do when I do what I do, 4x minus 4x is 0x, which is should send off all sorts of warning signs, but I do need to see what it equals. I subtract 20 from 20. Oh, look, 0x equals 0. Which means, ladies and gentlemen, there are an infinite solutions. Now, what you could have done to get that, ladies and gentlemen, if you remember, right, when we talk about lines, in order for you to get infinite solutions, these two equations have to be the same line. Now, I don't know if that's going to be the case on tomorrow's test or whatever, but one way we could have done this was, here, I'll do it over here. See if this makes heads or tails. You could have graphed these lines. Since this is slope-intercept form, it crosses the y-axis at -2, and it has 2 over 5 slope. 1, 2, 1, 2, 3, 4, 5. So your line is right here. Sorry about the end of that. If you were graphing this, I would graph this in slope-intercept form. If you to figure out where it crosses, if I cover up the y, it crosses the x-axis at 5. Oh, look, which ends up being right here. If I covered up the y, or the x, and solve this. A negative 10 goes into 20 negative 2 times, which is this. And if you look at it, lo and behold, it is the same exact line, which means there are infinite solutions. I don't know if that helped you, hurted you, whatever. I'm going to actually look. If you stayed this long, if you stayed the course, ladies and gentlemen, I'm actually going to see if I can find the answer to, I want to make sure I got the probability one right, because, you know, I struggle with math, and we're starting to get to the point of stuff where I don't teach. It all sometimes ends up being cumulative test 14b. Just going to give a quick answer to that problem. Number, the probability was, oh, good. Problem 18. Two identical numbers or rolling assumption. Labeled ones as well. My answer for problem number 18 is not. Oh, wait, sorry. Yeah, my answer is right. Thank you very much. You were doubting me. I was looking at the answer to the other test. So thanks, 8th grade, for listening. This ought to be a fun and exciting test. I think you'll enjoy it as much as I enjoyed making a video of it.